One way that matrices are useful in representing our points is that we'll be able to represent transformations in the plane using matrices. So we're just going to look at a kind of a review of the transformations that we have. So we've got translations, where you just move things around. Dilation, where you stretch or shrink things. Reflection, of which, of course, you reflect across different lines. And rotations, where you rotate generally around the origin. So let's just look at a few examples here. Perform each transformation described. So for A, translate 3 units left and 2 units up. So here's our point 1, 2. We move 3, 1, 2, 3 to the left, and 2 up. And we end up here at the point -2, 4. For B, dilate by a factor of 2 with center at the origin. And when we're dilating with our center at the origin, we just will take the coordinates and multiply by that factor. So we'll multiply by 2 here. So 1 times 2 is 2, and 2 times 2 is 4. So we end up at the 2, 4 point. For C, reflect in the x-axis. To reflect a point in the x-axis, our point, the x value stays the same, but the y value switches signs. So this becomes now 1, -3 down here. And for D, rotate clockwise about the origin by 90 degrees. So rotating by 90 degrees is kind of strange, but what we want to do is, and I'm going to actually kind of just draw a line here so you can see. So at this point, I'm now going to rotate it 90 degrees, okay, about the origin. We end up right around here, okay. This point is at 3, -1. You'll notice what happens here is the x and the y values swap positions, and then one of them becomes negative, okay. And that's always the kind of the case when we're doing our rotations by a multiple of 90 degrees. When we're doing a 90-degree rotation, you'll switch the x and y, and one of them will change signs. And you can just look at the picture to kind of figure out which one switches signs.